Let's resume our discussion. We talked about the limits, one-sided limits, and continuity for a simple example. This one. Now let us repeat the same thing, this time with a little bit harder example. This one. We have a bunch of asymptotes, so we expect some infinities here this time. Okay, let's go with that. And that is this example. Okay. First, what's the function value when x is equal to -2? X equal to -2 is up here. And on this vertical line, do you see any part of the graph? Any dot, any crossing? Nothing here. If it had been here somewhere, then you could have selected that point, but nothing there. So we say does not exist. Alright, next one. X is approaching the -2 from minus side. So left-hand side, we have to approach x equal to -2 from the left-hand side. Follow the left-hand side of the graph. And which y coordinate do we get? Going up and up and up and up and up, we get positive infinity. Vertical asymptote, so you have to expect infinity, but it's going up. Same thing, same in terms of asymptote, yes, but not exactly the same because the graph is going down this time, approaching to -2 from plus side. Same asymptotic, but going down, 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 so this time negative infinity. You have to expect infinity whenever you see asymptotes. Whether the graph is going up or down, that gives me the signs. Okay, finally, what's the limit without specifying the side? They're not the same. Left-hand side and right-hand side give you different values, so the limit does not exist. Getting some infinities may have been a bit of a challenge, but otherwise easy to understand. Now let's do the same thing at x equals to 1 here. At x equals to 1, do you see any crossing or point? I see nothing, so the function value does not exist. That was easy. Now a little bit more challenging here. X is approaching to 1 from minus side, so this is left-hand side limit. X equals to 1 here. Follow the graph from the left-hand side. Which y coordinate does it go? Up and up and up and up and up. Asymptotically, we have plus infinity again. Asymptotic behavior, vertical asymptote, so you have to expect infinity, but plus or minus, well, that's basically going up or down. Next, right-hand side limit. So follow the graph from the right-hand side, and which way is it going? Up and up and up and up and up. We get, again, positive infinity. Finally, what's this limit? Are the left-hand side and right-hand side limit the same? Yes, they are the same. So you can write positive infinity. Of course, if you don't want to write positive infinity, you can write just infinity, because without the sign, that means positive sign. Okay, next example. Limit, this time x is going to negative infinity. Limit, this time x is going to positive infinity. Okay, early on, y coordinate was going to positive infinity, either this way or that way. Y coordinate was going to positive infinity or negative infinity, going up or down. This time x is going to positive infinity or negative infinity. Y is vertical, x is horizontal, so that means left or right. Go left. Left, 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 and which y coordinate does it get closer and closer and closer to? Do you see asymptotic behavior here? I clearly see a horizontal asymptote. What is it? Y equals to -1. Next, x is going to positive infinity, so I have to go to right, 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 and does it get closer and closer and closer to a certain y coordinate value? Do you see horizontal asymptote? Yes, I do. What is it? Y equals to 0. If I don't see asymptotic behavior and this one is going up, for example, you can write positive infinity. Going down, you can write negative infinity, and sometimes unclear, but most of the time you're gonna get clear answer. Horizontal asymptote, or either going up or down, you can answer either way. We have some time, so let's discuss some commonly encountered infinities. How about this? 1 over x. In that case, we have either plus infinity or minus infinity, depending upon which direction I'm approaching to. But horizontally, we go 0 either way, and that's clearly visible from the picture. Let's see. How about the first example here? X is going to 0 from the left-hand side, minus side. X is equal to 0 is right here, going down, 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 so that's negative infinity. How about plus side? That's right-hand side, it's going up, clearly going up, so we have positive infinity. How about left-hand side? Left, 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 do you see horizontal asymptote? Yes, x, y equals to 0. And the same thing, right, 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 y coordinate is going to 0. So vertical asymptote, horizontal asymptote. This time exponential function and logarithmic function. Again, let's look at the graph, and here we go. Exponential function here, if I go to the right, if left first, negative infinity first, go to the left, exponential function behaves like this way. Y coordinate is clearly getting close and close and close to 0, so we have horizontal asymptote y equals to 0. So you can safely write e to the negative infinity is equal to 0. How about to the right? If I move to the right, I'm following this graph, and then it's just going up and up and up very quickly. So e to the infinity is infinity. Clearly you can see it. How about the log function here? Red graph. X is going to 0 plus, and then follow the graph. Looks like it's going down, 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 right? That's negative infinity there. How about to the right? It's slow, but going up and up and up and up. So log of infinity is positive infinity. You can see all those from the graphs. Trigonometric functions, okay. Some tangent functions, all right. At pi over 2, if I follow from the left-hand side, going to positive infinity. If I follow from the right-hand side, negative infinity. That's what the first line is all about. At pi over 2, right here, this way, positive infinity, that way, negative infinity. If I do something similar around the negative pi over 2, well, use your own reasoning. Left-hand side limit, right-hand side limit, at negative pi over 2. I'll leave that to you. How about arctangent, inverse tangent function? Here's a graph. Inverse tangent to the left-hand side, you get this horizontal asymptote, which is negative pi over 2. To the right-hand side, we get the other horizontal asymptote, positive pi over 2. You can clearly see those in these pictures. In short, if you draw the picture, if you draw the graph, you can see all these. Without the graph, it's going to be hard.